Let's continue with this horrible idea. I will add the if for direction 2, as I already written in the command up here on line 5. Direction 2 means that the y should increase and the x should increase. I can already see how this code is working in the first directions. So you can see that the ball is nicely reflected by the top and the left part of the playing field, but there is no code to check whether the ball has reached the bottom. So I'm going to write it now. This is a good place for such an if. I'm going to check whether ball y is too big. For example, is it bigger than 600? And if it is, then ball direction will now be the last possible value, 3. Apparently, direction 3 would mean the only thing that is left, and it is going to be the same direction left or right, but up down. Our y movement should change because we hit the bottom. So direction 3 would mean up right. And yeah, let's write such an if. So if ball direction is equal to 3, then the x will continue to increase, but the y will decrease. Let's see how this works. If you are really careful watching me, you have noticed that I missed one of the walls. Yeah, I've never written anything about this wall, and you can notice that something strange is going on after we exit the playing field. But I'm going to fix this soon. There is even another thing to fix. You can notice that the ball actually goes a little bit outside of the playing field, under the playing field. This means that something is even wrong with this condition. Do you know what it is? Well, if we don't want any part of the ball to exit the playing field, then we shouldn't check for the top part of the ball, whether it's outside of the playing field. We need to check for the first part of the ball if it hits the bottom. So, is the bottom of the ball hitting the bottom of the playing field? We can understand this if we write the mathematical expression for finding the bottom of something. We add the size, the height of this thing to the y of its top. And this way we will check whether the ball has hit the bottom of the playing field, even with its bottom part. Even if the bottom part of the ball is outside of the playing field, the ball will stop. And we can see that now I've ruined everything. The reason for what is going on now is that I've changed the condition for changing the direction to 3. You can notice that my code is now getting bigger, and so a lot of surprising bugs will happen. The idea that I'm trying to write is really hard, but try to not be scared. In the end of this lesson, we will have a really short and simple code working and reflecting the ball without any bugs and with really clever idea. If I don't want to ricochet to reflect the ball even in the beginning, I will change its initial position, and this is an easy way to fix our current problem. And also we can be happy that now the ball isn't going outside under the playing field with any of its size. And apparently the last problem we got with these reflections of the ball is that we don't have any check for the right part of the playing field. You can notice that when we hit this place of the playing canvas, the ball does not ricochet to continue moving left and up, because we don't have such a check to change ball direction to 0. We only change ball direction to 2, to 1 and to 3, but ball direction 0 is only the initial direction. I think I've done enough for now. I want you to make a really small if, just like those here, but be careful. Think of what part of the ball should exit the playing field and change ball direction to 0. You will pretty soon have all the 4 ends of the playing field done, and still we will have a new surprising big bug. It is going to be really interesting to fix.